we're here today to talk about FeatureCAM 2021 and how it's used in today's manufacturing for turn mill capabilities. FeatureCAM is one of the best out there when it comes to any kind of automating CAM software, and especially when it comes to turn mill capabilities. You know, it's great for just recognizing multiple features on a part and quickly creating a G-code. And so what is FeatureCAM? FeatureCAM, it's an automated CAM software. So it's in my opinion, it's a true CAM software. A lot of programs out there, they have design and software in the same package. FeatureCAM is a dedicated CAM software. So no solid, you can solid model in the program, but FeatureCAM is mainly meant for quickly creating NC code and to reduce setup time, reduce programming time, and to get a lot more consistent results for a whole variety of different machines out there. So what does FeatureCAM support? So it supports, like I said, a variety of different machines. We'll start here with milling, going from 2.5 axis, 3 axis, 4 axis, 3+1, 3+2 positioning, 5 axis, and all the way up to mill turn. And it supports multitasking like Swiss type lathes, part maker and turn mill, basic turning for just 2-axis lathes. It has a great feature for probing that works in conjunction with milling in any one of these different machines. For production, it also has the ability to create what's called tombstone fixtures if you're doing any kind of high volume machining while trying to maintain precision. So once you get done with programming a part, you have the ability to reopen that part in a multiple fixtures and a tombstone fixture file if you have if you're doing a lot of horizontal tombstone machining. It also has wire EDM capabilities for 2-axis and 4-axis. So if you're not familiar with what a feature is, so when we get done designing a part, it's usually going to have in the CAM world what's known as a feature, okay? And a feature is what FeatureCAM uses to actually create programming. So a lot of programs out there, you actually have to describe what the feature is, describe what the pocket or the hole or the boss is, and build it around that. Well, with FeatureCAM, we can simply import a part and have it run a diagnosis or not a diagnosis, but a recognition of all the features in the part. So whether it's a pocket or a side feature or a hole or a bore, it's going to recognize all those features at once and take from your tool library the best methods and best tools for creating those operations automatically. So that's what a feature is. It's made up of one or more associative operations. And from there, we can use those features to create our programming. And then the FeatureCAM, what it does is it's going to use the tools required. So if you have a good variety of tools and a very extensive tool library, it's going to take those tools and automatically select those features. And from there, we can create a program. So FeatureCAM workflow. So typically we'll start from an imported model, and FeatureCAM uses a lot of different file types. It supports a lot of different file types. It's not specific to what types of files that you want to use to program, whether it's a step file, a SolidWorks file, Inventor. It supports all those, which I'll get into here in a second. After we import a model, we have the option to set up our stock. So the neat thing about FeatureCAM is it's very great for just walking you through the process of setting up your part. And once we import a part, we have the option to choose our stock manually, or we have the option to automatically start setting up our our stock wizard, which walks us through the parameters of the part and allows us to pick the stock based on the parameters of the part. Then we can come into machining prep. So this is where we're going to start our setup. This is where we're going to define our work coordinate system, our location of our work coordinate system, and any kind of automatic feature recognition. We're going to start everything we can pull from that part automatically. We want to do that in the beginning, and then we want to boil it down from there, or refine it from there. So once we run automatic feature recognition, or excuse me, after we've set up our stock and set up our setup, we can prep the model and create curves to actually use in our programming process. And from there, we can create features to program from and then simulate. Once we simulate, we can look at our results, look at our G code, look at how the program is using the tools and what operations. And then from there, if we're not satisfied with the results, we can go back and revise the features that are in the operations. Excuse me, the operations that are that were programmed. Once we're happy with that, we can then go on and generate NC code and start cutting chips. So a lot of people out there using FeatureCAM are finding that it's with its automation and its ability to pick features automatically and fast programming time, it all just kind of snowballs. So with faster programming time, we're able to meet delivery schedules a lot faster, which makes us more marketable in manufacturing, right? So we're able to it really is able to drive marketing. So we're able to with improved time and programming, we can get quotes out faster, making us a lot more marketable, and getting estimates out quickly. And especially if you have a lot of machines, if you're supporting a lot of machines that use 3-axis, 4-axis, turn mill, you're going to be doing a lot of programming, and so you're going to want to have a lot less programming times, and you're going to want the program to do a lot of this work for you, because you're going to want to keep those parts and volume going through your machines while maintaining quality, which again, getting back to marketing, makes you a lot more marketable. So turn mill capabilities. This is what we're here to talk about today. And in my opinion, FeatureCAM is one of the best programs out there for turn mill. Not only is it a great turning program for just recognizing turning features, but if you have a machine that supports live tooling or a turn mill lathe, then FeatureCAM is the way to go. So today, we're going to walk you through how we can utilize FeatureCAM with turn mill machines and programming. We're going to show you how we can automatically recognize features around the part, automatically recognize features in the C-axis and B-axis. So it's very, very versatile when it comes to programming. We're gonna show you how to run feature recognition and also pick features manually in kind of a semi-automatic way to give you a little more control of how you program the part. So with turn mill capabilities and just about any part that you're programming in FeatureCAM, we're able to actually get a machine simulation that shows us how we can prevent collisions. And we can simulate fixtures, subspindle transfers, and tools and holders. And it really is a detailed way. After you get done programming, its simulation is great for just looking looking at how the part and the machine is interacting together, and so you can kind of avoid crashes and adjust your machine settings based on your programming. All right, that said, I'm going to go ahead and hop into FeatureCAM, show you how we can set up a part, do some turning, show how we can pick features, turn mill features with live tooling, and show how we can do some 5-axis tilting with some of these features as well. All right. All right, so hopefully everyone can see my screen. So I've imported this part into FeatureCAM, and whenever I import a part into the FeatureCAM interface, what it's going to do is it's going to ask me how I want to set it up. So in FeatureCAM, we have whenever we're starting a new document or we're importing, we have the ability to, excuse me, we have the ability to pick from a mill, turn mill, any kind of operation that we're doing up here. What unit of measurement we want to start with, and whether we want to have an initial stock dialog come up when we import a part. So I've imported this part, and we have already defined some stock with our wizard, but if we want to go in and actually manually adjust our stock, we can come right here into stock properties and adjust the dimensions, whether it's a block, it's round, if it's multiple sided, or if we actually have a solid piece of stock that we've already modeled and brought in here under our solids. Also in stock properties, we have the ability to tell the program that it's yes, we are indexing around the z-axis, dictating that this is a turn mill part. So since we've already specified that this is a turn mill part when we open this part or imported it, we don't really have to do anything here. So we'll say okay. Looks like I'm on block, not round. And now the first thing we want to do when we are doing any kind of turn mill feature is we want to do a face, right? So what I like to do with FeatureCAM is I like to first run what's called automatic feature recognition. What this does is it's going to analyze the entire model and pick out all of the features that we can use as operations, so we can program from. And what it does is that when we run this, is it creates what's called curves, and that's the general way that FeatureCAM, the geometry that FeatureCAM uses to program is using curves. So it's going to take, say, this pocket here, and it's going to put this into almost like a line structure, and from there we can use that to program with, and it gives you a lot of control when you're programming. So the first thing I'm going to do is I'm going to come here to AFR. You'll notice it highlights my entire model. And if we had multiple models here, we have the option to drop down and select which one we want to analyze. So in this case, we've only got one model, so we'll keep that. We'll keep that alone. We'll go next. If we have multiple setups, we can check which one we want. In this case, we just have our first setup. And now we're ready to look at our features. So we can see the features that it picked out for us, and it's given us a list, right? So it's seen that we have some side features here, some flats. We have these front pockets, we have these front holes. It looks like it didn't pick out these pockets here, but if I turn it this way, we were able to get some contours for our turning. So what we can do from here is we can go ahead and we can choose to leave some features behind, or choose to keep some. So what I like to do is I like to just kind of walk through each of these features. So if we have a bore right here, this front hole, it's trying to, looks like it wants to bore that out. I don't want it to bore that. I'd rather have it drilled. So I'm going to uncheck that. I want to keep that face because, you know, this is a turn part. So of course I want to face off all of that extra material in the front. Our hole, yes, I want to actually drill that out first, and then maybe we can come in there with a bigger drill, not a bore. I want to keep that hole. I want to keep that hole. And then looking at these side features in the front, it's looking like it didn't pick those how I wanted it to. So I'm going to go ahead and check those off, just because I'm going to show you how we can get those pockets better aligned to that angle with by tilting the tool. So I'm going to check those off. Come to that side. You'll notice that in FeatureCAM, sometimes it tries to create a side feature with the tool hanging out in a line with the Z axis. It's one way to actually mill that, but what I like to do is I like to keep the tool as short and stubby as possible. So I'm actually going to try and get this tool to come in normal to that surface. That way we can shorten up the tool. We can use a bigger diameter of tool and reduce chatter, reduce tool wear. So I'm going to uncheck that side surface for now, but I do want to keep that last turn surface. You'll notice that our automatic feature recognition did recognize a nice turn surface. So we will go ahead and finish that. And you'll notice in our first setup, I'm going to back up here for a second. Going into setup, whenever we import a part, we're asked to start this setup process. And again, it asks us a bunch of different questions, whether we want to start with the main spindle or the sub spindle, setup names, our fixture ID, where we want to position our zero. So this is all called out in our setup. So with the import, it walks us through all of this information. But if we ever want to go back and change any of this or redefine any of these parameters, we can come right back here into setup and pick our location, whether it's aligned to our stock face or an existing UCS, or if we just want to manually pick a location. And also in simulation, if we have a machine file that we want to use for simulation, we have that option as well. So that's just a little, I wanted to back up there and show you how easy it is to set a part up and to define some of those parameters. So getting back to our turn mill features here. So with automatic feature recognition, we found a face. We found these two holes on the front here. I found this front hole that's just going to drill out for me. And then if I want to come back in and drill that to size, I can. And then we also have this turned feature. So just with that alone, let's go ahead and see what we get with our simulation. I like to put it on 3D mode. That way, we just get a good view of any gouges or just a good visual of how the part's gonna run. And whenever you're working in FeatureCAM, another neat trick down here is to look this is a list of what you're using as far as your tool crib, the machine you're actually using for your simulation. So these are a lot of quick ways that you can access a lot of this information. So I can double click on a lot of this information down here, and it gives me a lot of options and shows me what tool crib I can switch from. If I want to, if I have a specific tool crib I want to pull tools from, this is a quick way to access a lot of that information. So we'll keep that alone. In simulation, we'll go to our 3D. I like to slow that down. Okay, so right away, we didn't need to touch any of that stuff. We've already have our holes, our face, and a nice turned surface. But you'll recall that I didn't, it wanted to, we'll start with this side surface here. It wanted to hang that tool out pretty far and actually mill that surface off with the length of the tool touching that side right there. So what I want to do is I'll show you how I want to set this up. So along with AFR, we also have what's called IFR, which is interactive feature recognition. So this is where we can start picking features manually, and I like to call it semi-automatically because it does give you the option to recognize features when you point it to a surface, and you can automatically recognize features depending on the surface that you're pointing it to. So in features, I'm going to go ahead and it's asking me what type of feature do I want to create. It's a turn mill feature. So I'll go next. And I want to mill off that flat. Again, I want the tool to be normal to that. So in this case, it is a side feature. So a side feature means that we're going to be milling with the side of the tool and with the front of the tool, because we have this face we want to mill off, but we also have this side that we want to cut. So I selected a side surface, and then I want to check this box down here. I want to say extract with feature recognition. So I'll go next. And again, the neat thing about FeatureCAM is whenever you're creating features or you're importing a part and choosing your stock or your setup, it's going to walk you through the process, which is really handy, especially if you're learning. So what it asks me now, since it knows that this is a turn mill feature, I'm not setting this up along the z-axis. This is going to be around the index axis, so it's going to be about the z-axis. In this case, I want my tool to be normal to a certain surface. So now it asks me how I want to pick that surface. I'm going to go ahead and pick that surface right there. I'll go next. And now it asks me how I want to select my side surface. Do I want to select it just by picking it with the mouse? Do I want it to recognize horizontal surfaces? Do I want it to just automatically recognize any side features within these parameters? I always like to start with automatic. Always start with that first, because sometimes FeatureCAM picks it for you and saves you a lot of work. So I'll go next, and sure enough, it gave me what I wanted. It gave me this curve. So again, when we're creating a feature, it's going to create the feature for you, but it's going to leave this this geometry called curves for you. And from this is what we can use to actually modify and to define later if we're unhappy with the results of the programming. So after we have defined our where we want the tool to machine off from the side, we're going to go ahead and select all. So it already recognized that side that we can use. We'll go ahead and select that, and we'll hit finish. And now we have a side that we can use. So whenever we create a feature, we now have the ability to reopen it back up. So it automatically opens for you and allows you to dictate the dimensions of the side or pocket that the feature you're using, right? So we have the ability to come in here and actually define the parameters and the geometry of that feature. The location, if we want to go back to using a rotary Z tool, we have that option. But again, I'm going to stick to the rotary X tool because I want to use the nose of that part. Strategy, so if we want to come in here and define the behavior of how that tool is going to cut that side. Side control, so if we want to reverse sides. And some other miscellaneous information we have here about how the tool is going to behave in the feature. So we'll say OK to that. And let's go ahead and run our 3D sim and see what we get. So you'll notice that it wants to start that side first. And that's what it's doing is it's recognizing, it wants to do this side first, but it's recognizing a lot of material out here that we don't want to cut. So one thing that we can do when we're programming in FeatureCAM is we want to look at our results tab over here on the right-hand side. And what this allows us to do is it allows us to order these tools with this automatic ordering or this manual ordering. So if we want to actually take our features and move them around, if we want to do a turn feature first, and then do if we want to face first, and then we want to turn it first, turn a second, and then do our sides and pockets and holes last, we can do that all here with these operations. So what we can do here, what I want it to do first is I want it to face first, because that's a pretty common starting feature whenever we're doing any kind of turn mill parts. So I'm going to add my rough pass finish, my rough and finish face. And then what I want to do is I want to turn this down. So I want to drag these operations up. So I have my face, I have my turn, and now I can come into the side and carve that out. So now we've moved those operations. Let's see what we get. So you'll notice that the tool was machining kind of out in blank space here. We don't want that. So the neat thing about these operations is when I come here to this side, I can come in here to any operation and I can dictate a lot of the parameters behind it, the tools, the how it behaves around in the boundary of the feature. So for instance, in this roughing pass, if I come over here to the milling tab, I have a lot of different options of how I want this to cut. If I wanted to do, for instance, if I want to do different Z increment, level increments, I have that option. In this case, I want to hit my total stock. And if you don't know, if you have the drawing in front of you, that helps. But if you don't actually know what that distance is, you can come up here to Interrogation, and you can measure a lot of surfaces around your part. And what I like about Interrogation is you can, it doesn't have to be straight. It's going to take a nice straight measurement because you're dictating the axis that you're aligning it to. So in this case, I want to do a distance measure, and I want to pick it along the Z axis. So I can simply highlight that, select that feature, select that opposite edge, if I can grab it, and it's going to give me 50. It looks tilted, but again, since we're measuring parallel with the Z, it's going to give me the answer I'm looking for, which is that 50 millimeters. Again, I'm in metric with this part, but the same applies if you're using English units. Getting back to my side feature, I can come here to my rough, go back to my milling, and then under total stock, this is where we're going to define our boundary. So remember, that tool is just cutting in blank air. I don't want it to do that. That's just a lot of wasted machining time. So what I want it to do, since I already have my feature made, I'm just going to go ahead and say 50, because that was the boundary or the measurement that I took off that feature. And I'll just say set, and I'll apply it. I'll say OK. Back in my 3D mode, turn that down, and you'll notice we're not machining in blank space anymore. Now, another thing we can do when we are doing turn mill parts is you'll notice that we have a lot of the same features. We have a pattern around this axis. So we just did this side feature, but what if we wanted to do that pocket along with that side feature. So, or excuse me, what if we wanted to mill that this face here, but then also pocket that as well right afterward? So what we're going to do, kind of come right back up to feature. Yes, it is a turn mill feature. In this case, we're going to go ahead and select pocket this time. We're going to leave it on extract with feature recognition. We're going to go next. Now what we're going to do is we're going to, once again, just like we did our first flat surface here, we want it to analyze all features within that boundary. So I'll go next. I want it to automatically recognize those features, so I'll go next. And it automatically recognized the pocket that we want to machine. It asks us, do we want to unselect or select all? I want to select that one. We'll go ahead and go finish. And again, with any kind of features that you're creating, we do have the option to come in and change these manually. So here we have the profile of our pocket. We can come in here and change these manually. So if we have the drawing in front of us, the drawing says, you know, this is this depth is X millimeters or X inches. We can input these manually. Or another handy trick is, do you see how these are highlighted in blue? These are, you're able to pick those names, those titles, and come down here and actually pick a depth. So I can click on that surface, that top surface, and that top surface, and I have a depth. Looks like I picked some of the wrong geometry there. But it automatically knows you're able to pick a lot of that geometry manually. So now that we have that pocket, what we can do is, we know that we want to mill that face off flat, but we know we want to pocket that as well. So, and we know we want this to be all the way around. So what we can do is, with our side pocket, or excuse me, with our side feature and our pocket, I can highlight both of those, and then I can come up here to our features and manufacturing, and I can say I want this to group together. I want this to machine as a group, right? So this is it's gonna mill it flat, and then it's gonna do the pocket. So what I've done here in my setup is I've actually grouped these two. Now that I have this group, I have the option to go ahead and pattern that around. So I'll just go ahead and select my group, come up here to pattern, hit radial plane, and now I have a dialog box or a wizard that I can come in and walk through the steps of defining how I want that group to pattern around my part, which is really handy. So if I come here to diameter, I can go 0, because I don't want it 100 millimeters off the part. I want it actually on the features that I've chosen. I have, in this case, I have 6 instances around the part, and then I want to space these by 360 divided by 6. And whenever you're creating features, I always like to preview what I'm doing first, right? That way we get a good visual. And you'll notice once I've created those, it's snapped right to all those features. I'll go next. And I'm happy with that. So I can go ahead and go finish. And now what it's done is it's grouped all of those features in one pattern. So now when I go home, simulation, go 3D, it's going to go ahead and do all that for us. Okay, so now what I can do is, let's say we want to do these features here. Well, we can do the same process, but you'll notice that we have we have a kind of a mirrored feature. So we have two pockets with a hole in each of their bottoms, and we want to mirror that to the opposite side. So what we can do, just like how we did feature recognition for these features, we can do the same here, but we can group them in a different way. So back up to our features. Yes, it's a turn mill feature. I want to create a side because these are usually a pocket is going to be an enclosed feature. A side is going to be open like this. I want to extract with feature recognition. Go ahead, pick all features normal to that surface. So it's going to recognize all features within that plane that is a side. Go next. Yes, I want it to automatically recognize. You'll see right away it's chosen those for us. Select all, finish, and we have our side. Now we can start with our holes. So we can go feature, once again, turn mill. We have a hole. I want to extract with feature recognition whenever we can. Again, pick our surface. Go next. I want it to recognize and construct multiple holes, but when we're recognizing holes, we have a lot of different options. So with this, I don't want it to recognize these sides as, say, a counterbore or something like that. So sometimes when you're doing holes, it might recognize this big side feature as maybe a counterbore feature to the bottom hole, and which isn't true. So I want to exclude holes that are, say, less than 10 millimeters. So I'm going to go ahead and check that. I'm going to go ahead and go next. And you'll notice that right away within that plane, it recognizes those two holes. What I don't want it to do is I don't want it to merge into a pattern, right? So because what I want to do is I want to merge these two sides along with these two holes and then be able to pattern it to the opposite side. So I'm going to go ahead and uncheck that box. We'll go ahead and select all, and we'll finish. So now what we have is we have a side feature, and we have our two holes. But now what we can do is we can pattern this, right? So once again, coming up to our features, let's go ahead and select these two sides and select those two holes, and let's group them. We'll say okay. Actually, one thing I do want to do, I don't want these holes in the group. So I'm actually going to delete this group, and I actually just want these two sides to be mirrored. So I'm going to group these two sides, add it to a group, select OK, and then I can go ahead and add it to a radial pattern. Diameter of 0. There's two instances. Since they're mirror opposites of each other, we'll just say 180. We'll get a good preview. You'll notice we were able to mill out those slots perfectly. Go ahead and finish that, and we'll simulate. All right. So you can see we were able to get our all of our sides and our holes. Now what we can do is we can go ahead and tackle how we can get our tool tilted to get this face in these pockets, right? So what we can do now is same process. Since we're on a turn mill part, and since we specified that that our machine actually does have 5th axis tilting. So if this machine isn't down here, if you don't have a machine file or a post that supports tilting, tool tilting, or 5-axis tilting, then you might get some weird errors. But in this case, we have our Mazak Integrex, which is going to give us the tilting that we want. So for features, yes, it is a turn mill feature. Go next. Now in this case, we don't have any sides that we need to take off. So we're not actually going to use the side of the tool to mill a feature. We are just going to do a face. We do want to extract with feature recognition, and we wanted to analyze surfaces at that angle. So you'll notice that when I tilt this model, you'll notice that I click that surface and it actually picked that tool location for us. It said, okay, now the direction of our tool is in that Z direction. We'll go next. And now that I've already selected that face, that's the face that I actually want to mill off, right? So I can go next. It automatically recognizes the thickness from the edge of the stock that I want to take off. In our strategies, we can decide how we want to face that off. If we don't want to finish pass, if we want to climb mill, if we want to connect our step overs with arcs, we have that option. I'm just going to go ahead and say finish. We'll say OK. Now, I'm pretty confident that that's going to face off, so I'm just going to go ahead and move right along into my pocket. So we'll go features. We have a pocket that we want to analyze, extract with feature recognition, normal to that surface. We'll go next, automatically recognize that pocket, select it, finish, we're good there. And then lastly, we'll do our holes. And we'll say finish. Now let's see what that gives us. So again, pretty automated when it comes to picking features. You can select a surface, have it analyze that surface for any features that you want to pick out, and it's going to do it for you. Now we can go ahead and once we've gotten that surface, we can maintain our process. We can just go ahead and go group, and we can add features to the group that we want. But I also want to get that face in there as well. So we can group all that together. And now we can come over here to our pattern, radial pattern, 0 because we want to be right on the actual part. 2 instances, space it by 180 degrees, and we'll go finish. Come home, and we can simulate the entire part. Now, once we get done with programming, if we're not happy with any of these results, again, we can always come back in here to any of these features, come to our rough and finish, edit any of these parameters, the tool, the feeds and speeds, how we want these features to behave, right? How we want the tool to behave around the actual operation. And now what we do is once we have our features, we come over here to our results, and we can look and see how it's going to actually machine, how it's going to machine in process. So if we come here to sim mode, go to center line, I can go ahead and walk through each of these operations if I just go single step, and you can see that arrow moving down as I'm clicking through each operation. So it's just a lot better way and a lot more refined way of looking at your operations and refining your operations to give you a better machining time. Also over here in the results section, we have our details. So this details each operation, speeds and speeds of each tool, and we also have our NC code that we can look at. So this is what's going to give us our, we can save this out and repost it. We can see if this looks right before we actually save the file to send it out to the machine. So that is all I have for you today about turn mill capabilities in FeatureCAM.